Hello everyone. In this video, let's discuss how to write a program to flatten binary tree to linked list. Given the root of a binary tree, flatten the tree into a linked list. The linked list should use the same tree node class where the right child pointer points to the next node in the list and the left child pointer is always null. The linked list should be in the same order as a pre-ordered traversal of the binary tree. Here they have given an example 1. So here, according to the pre-order traversal, first we'll visit the root 1, then we have to go to the left child. Now again I have to visit the root 2, then I have to go to the left child. Now again I have to visit the root 3, then I have to go to the left child, that is null. Then go to right child, that is also null. Then go back to the previous subtree. In this previous subtree, root over, left child over, go for the right child. Okay. So here this is the root. Then left child is null, right child is null, then go back. In this subtree, root over, left child over, now go to the right child. Okay, now this is the root. Now left child is null, go to the right child. This is the root, left child is null, right child is also null, then go back. The complete traversal got over. Now when I perform the pre-order traversal, this will be the output. So I have to make all the left child as null, and I have to traverse through the right child so that I can form it as a linked list. Let's take a second example. If the root is null, I have to return the empty list. If the root has only one element, I have to return the particular element. Let's discuss the logic in detail. So here they have given a binary tree. Now we need to flatten this binary tree into a linked list. So first what I'm going to do is I'm going to take an object called current and the root value will be stored over there. Okay, I'll take an object called current. I'll be storing the root value. Root value is 100. Now current is pointing to the address called 100. Fine. I have to take a loop and I have to iterate until the current becomes null. So while current not equal to null. If current is not equal to null, I'll go inside the loop. Okay. So first what I'm going to do is I am going to check whether left child is not equal to null. If current.left is not equal to null. Why am I checking in the case? Here they have mentioned left child should always be null. So that is why I am checking a condition left child is not equal to null or not. In case if left child is equal to null, I don't want to do anything. I can go to the next right child. So current equal to current.right. So if left child is equal to null, I'll not go inside if condition. I'll go to the next right child. So current nodes right child, I'll go for it. In case if left child is not equal to null, I have to make that as null. And this should be converted into pre-order traversal. So in case if left child is not equal to null, I'll take one more object called temp. So that particular node has to be stored in the object called temp. So I'll be taking an object called temp. So here current is pointing to 100. Current.left is 200. That is not equal to null. Condition is true. I'll go inside. That particular address will be taken. That will be stored in an object called temp. Now temp is pointing to the memory location called 200. Fine. After this, I have to take a loop and I have to iterate until this node's right child becomes null. So while temp.right not equal to null. So until that particular node's right child becomes null, I have to iterate. Temp equal to temp.right. So now temp is pointing to the memory location 200. Temp.right is 500. That is not equal to null. Go to the right child. Now temp is pointing to the memory location called 500. Check temp.right not equal to null. So temp.right is pointing to null. So now temp is pointing to the memory location 500. Temp.right is null. Condition becomes false. If the condition is false, I'll come out of the loop. After coming out of the loop, I have to do 3 steps, which is I have to make the current nodes left as null, right? For that, temp.write value. So temp.write value which is here, which means after the completion of the pre-order traversal, I have to go to the right child. So how does the pre-order traversal work? Root, left child, and then I have to go to the right child. So here this is the last node in the left subtree. So here next I have to go to the right child. So in temp.write, I have to store current.write. So current.write is 300. That will be taken and that will be stored in temp.write. So done. After this, in current.write, I have to store the current.left. Why am I storing? Because I have to make current.write left as null. Current.left is equal to null. So in current.write, I have to store current.left. So here I will store 200. And then I have to store current.left as null. Because I have to perform pre-order traversal. While making a linked list, I always have to go to the right child address. That is why I am doing these two steps. Okay. After this, if condition becomes over, now current equal to current.write. So current is pointing to the object called 100. Current.write is 200. Now current is pointing to the memory location called 200. Check the while loop. Current not equal to null. Yes, current is not equal to null. Check current.left not equal to null. Yes, current.left is not equal to null. If current.left is not equal to null, that address will be taken and that will be stored in an object called temp. Now temp is pointing to the memory location called 400. So here what I have to check a condition saying that temp.write not equal to null. Actually temp.write is equal to null. Condition becomes false. I will not go inside the while loop. After what I have to do, in temp.write, I have to store current.write. Current is pointing to 200. Current.write is 500. So 500 will be taken. That will be stored in temp.write. Afterwards, in current.write, I have to store current.left. Done. Now current.left should be null. So after this if condition, I have to go to the next write node. So current.write is 400. I'll go to the memory location 400. Check the loop again. Current is not equal to null. Yes, current is not equal to null. If current is not equal to null, I have to check one condition that current.left not equal to null. Here current.left is equal to null. I'll not go inside the if condition. I'll go to current equal to current.write. So current is pointing to 400 now. Current.write is 500. Now current is going to point to the memory location 500. Check the value of current not equal to null. Yes, current is not equal to null. Check the if condition. Current.left not equal to null. Current.left is equal to null. I'll not go inside the if condition. Then automatically I'll go to the current.write. Current.write is 300. I'll go to the memory location 300. Check current not equal to null. Yes, current is not equal to null. Check current.left not equal to null. Current.left is equal to null. So I'll not go inside the if condition. I'll go to the right child of the current node. That is 600. I'll go to the memory location 600. Okay. Next, current not equal to null. Yes, current is not equal to null. Current.left not equal to null. Current.left is equal to null. I'll not go inside the if condition. I'll go to current equal to current.write. So current.write is null. Now current is pointing to the memory location called null. Check the while loop. Current not equal to null. Current is equal to null. I'll come out of the while loop. That's all. I have completed this question. Now when I perform traversal, it should form a linked list. So right child node is the address of the next node of the linked list. So first I'll be pointing to root, that is 100. Right child 200. Okay. So let's traverse this linked list. I'll print the data here. Okay. First I have to go to the root. Root is the memory location 100. Data value is 1. Okay, 1. Then right child is 200. Okay, next node 200. That is 2. Okay, next node 400. Okay, 3. Next node 500. Okay. Next node is 300. Done. 5. Next node 600. 6. Next is null. That's all. I have traversed the binary tree, which means I have converted the binary tree into a linked list. Let's implement it as a program. So first I have to take an object called current. I have to store the root value. Done. After that, I have to take a while loop and I have to check current is not equal to null. If current is not equal to null, I have to check the if condition. If current.left not equal to null. if current dot left is equal to null, I don't want to go inside the if condition, I'll go to the next node. So current equal to current dot right. In case if current dot left is equal to null, I have to take that particular node's address that should be stored in one more object called temp. So current dot left. After this, take a while loop and iterate till the right child becomes null. So while temp dot right not equal to null, I'll go inside temp equal to temp dot right. Done. After the iteration, what I have to do? I have to change the address. So which is in temp dot right, I'll store the current dot right. In current dot right, I'll store the current dot left, and then current dot left will make it as null. That's all. Finally, I have to return from this particular function. So I have to return inside. That's all. Let's run the code now. As it passes the test cases, let's submit the code. As it passes all the test cases. That's all.